Hi, welcome back. We're in the final lecture, lecture 24, where I'm just providing a course overview. And in this second segment, I'll talk about the segment of the course where we talked about multiple regression and simple regression. So this actually was perhaps the largest chunk of the course, was simple and multiple regression. It probably took up the most amount of lecture time. So just to recap a very basic distinction, which is probably very clear by now. Remember, simple regression is just a regression analysis where you have one predictor in the regression model. Whereas multiple regression, you could put in as many predictors as you want. And of course, that was the more difficult part. That's what we spent a lot of our time on. But that segment of, or that section of the course is also where we introduced inferential statistics and this idea of null hypothesis significance testing, which is also a really important piece of this course. So null hypothesis significance testing in the context of regression, remember, could be used to test the statistical significance of individual predictors in a model, or it could be used to test the overall value of a model. So remember, you could test the proportion of variance explained, that R squared. You could see if it accounted for a significant portion of variance, where the null hypothesis would be that it accounts for zero variance, the alternative being that it accounts for significantly more than zero. Or you could use that to compare multiple models, as we did in several cases. But introducing inferential statistics and null hypothesis significance testing at that point in the semester brought up all of these other issues, right? So that's why this was sort of a big chunk of the semester. So we had to talk about the idea of random and representative sampling, the idea of sampling error, and this notion of sampling distributions, which is always one of the hardest things for students to wrap their heads around. So again, you might want to go back and review that part in particular. The idea of sampling distributions, I think I used the example of distribution of sample means, and how that leads to the central limit theorem, which is essential to understand the idea of statistical significance, because it's where those p-values come from, right? The assumption of some sampling distribution, and then we assume a null hypothesis to be true, we do a study, we calculate our statistics, and then we calculate, well, what was the probability of obtaining this outcome given the assumption that the null was true? All of that comes from these ideas of sampling, sampling error, standard error, and central limit theorem. Of course, then I wanted to highlight a lot of the problems associated with NHST. So we did that in a specific lecture and then talked about some of the remedies. Again, because that's sort of a controversial topic, I want to review it here. I provided you with this nice acronym, which I think is sort of funny. I've never seen anyone do that before, so this will hopefully help you remember. What are some of the problems with NHST? Well, use the Bayes acronym, because remember, Bayesian inference is an alternative procedure to doing this kind of inferential testing. So the Bayes acronym stood for NHST is biased by sample size. There's an arbitrary decision rule, right? We just pick alpha of 0.05 lots of the time. I call it the yokel-local test because a lot of researchers use it because it's the only thing that they know. It's the only thing that they were taught, and they just go on using it over and over again, even though in a lot of cases it might not be appropriate. It's error prone, so we know that we're always susceptible to a type 1 error or a type 2 error. And remember, it also forces us to engage in what I called shady logic. Remember, the modus tollens logic that we use in null hypothesis significance testing would be fine if we didn't engage in this probabilistic reasoning. Once we made it probabilistic, as I showed you back in those lectures, it became what I call shady. So that's the Bayes acronym to remember these multiple problems associated with NHST. So should you abandon it altogether? Well, some people say, yeah, you shouldn't be doing NHST. Maybe you should be doing Bayesian inference or just doing something else completely, like non-parametric statistics, resampling methods, for example. My preference is just to be aware of those problems by taking a course like this, you're now aware of them, and then remedy those problems with supplemental statistics, like estimates of effect size, like confidence intervals, by engaging in model comparison. So don't just compare your model to the null, compare multiple models. So theory A predicts model A, theory B predicts model B. Test those two models. That's a stronger form of hypothesis testing. Also, replicate, replicate, replicate. If you find a significant result, replicate it. That way, you're protecting yourself against the possibility that you've conducted a type 1 error, or you've committed a type 1 error. And be aware of the statistical power that you have in your studies so that you're not making yourself susceptible to type 2 errors, right? Because if you're underpowered, you might be missing effects that are true and really exist out there. So by being aware of the problems of NHST and applying these remedies, I think it's fine to proceed with NHST. So in the context of simple regression, just remember the regression equation. There's the regression constant, that's the predicted score on y when all your x's are 0. We could get unstandardized estimates and standardized estimates. And remember, we can calculate residuals and look at those residuals to see if we can improve our model. And in this course, what we focused on was the method of ordinary least squares to estimate those regression coefficients. Same thing for multiple regression, it's just now we had to estimate multiple regression coefficients all at once. So to do that, I had to show you a little bit of matrix algebra. So we had that one lecture on matrix algebra. But once you learned how to do that, you could see how all the regression coefficients in a large model were estimated together at once. And again, we just dealt with things like the residuals, model comparison, and we used ordinary least squares to estimate those coefficients. Finally, the last thing we did, and I think the most complex types of analyses we covered in this course, and that's what my students here at Princeton typically say, were moderation and mediation. So those are just forms of multiple regression that allowed us to test specific hypotheses.